Okay, so this is the final section of this chapter. We're graphing linear systems of linear inequalities, and we know systems are more than one, right? So the previous section we did linear inequalities where we graphed a line and shaded. Now we are going to graph two lines and share a common area. One thing I want to kind of go over, just kind of mention that anytime you draw two lines that intersect, you're going to have four area quadrants. Like this might be 1, 2, 3, 4. If I have more lines with less or more of a slope, I could see 1, 2, 3, 4. How there's basically four sections whenever two lines intersect. Okay, so this section is going to be drawing two lines, and we know if we graph a linear inequality, we're going to shade either the top or bottom of that line, but we are now taking into account a second line. So we are essentially going to be shading one of the four quadrants of the two lines that are graphed, okay? So all we need to be able to do is graph one line, and we're just putting them on the same graph. So you graph the first linear inequality, and you could do this, you could shade lightly or not. What I like to do is draw two different colored lines so you can see which one goes with which, and I'm going to show that in a couple examples. But if you can see, if we are just graphing y is greater than or equal to x minus 8, I would start at -8. I put my dot, I go up 1 over 1. It's a solid line, and it's y is greater than, so everything shaded above it. That would be the just shading that inequality. Over here, you start at 4, 1, 2, 3, 4. There's that dot. You go down 3, 1, 2, 3 over 1. That's how we graph that line, right? Starting point 4, -3 over 1. And we see that it's y is less than, so we're shading below. So essentially, all we're doing today is taking these two and we're merging them together. So you can see our four quadrants, right? 1, 2, 3, 4. Where they intersect, where they share the shaded region is our solution. So these are the numbers that if I plugged any of these points, like even 0, 0, for example, 0 and for x is 0 greater than -8, yes. 0 and for x here is 0 less than or equal to 4, yes, that works out. So we're looking for points that make both those true. This is the part that they would share, right? So if I go back here, this is shaded above it. That's everything in the blue. This one's everything below that. And this green, right? So where they shade or where they share is this quadrant right here. Wow, that looks like a mess. Okay, let's do some sample problems, because doing sample problems is the easiest way to really comprehend this section. So let's go ahead and go to this. Okay, these are already in slope-intercept form. Now what I like to do when you guys are working on these types of problems, I like to use two different colors. If you have colored pencils, it makes it very easy to see. So I'm going to do this one in blue, and I'm going to do this one in red. So I'm going to graph each line first. So in this one, for the blue, I'm starting at 4, so I go up 4. 1, 2, 3, 4. I put my dot there. Now I have to do my slope. My slope was 2, or remember, 2 over 1. So I can go up 2 to the right 1, and I put a dot there. Now I have to draw my line. It's going to be dotted because there's no line underneath. So I am going to put a dotted line and extend it down. All right. So the reason I like to use the colors is because now I can see this blue line and I can read this y is less than. I know it's going to be on this side where I shade it, but I'm not going to shade it yet. I'm going to now do the red one. So I look at my starting point, -2. I go down 2 and I put it there. And my slope is -3 over 2. Now remember, with a negative slope, it could be -3 over 2 or 3 over -2. Not both. That makes it a positive, right? Negative divided by a negative is a positive. So anytime we have a negative slope, we have to associate it with the top or the bottom. So I could go down 3, 1, 2, 3, to the right 2. Or I could go up 3, 1, 2, 3, to the left 2. And that's going to make ourselves a negative slope. This is or equal to, so we know that this is going to be a solid line. All right, so now let's talk about where we are going to shade. So you can see the quadrants here, right? You can see, I'll just number them, 1, 2, 3, 4. All right, no particular order, that really doesn't matter. So what I do now is I analyze my blue line. My blue line is this one, and I know that because I put a little blue dot next to it. This is y is less than. Remember, it's pointing, opens to the bigger side, points to the smaller side. So y is less than. So what I tell myself right now, below this blue line is quadrant 3 or 4. It has to be one of those two. It's not going to be 1 or 2. So I kind of just ignore those, right? So it's going to be 3 or 4 to where I am going to need to be shading. So I'm just going to get rid of those. All right, that's my cue for blue. Now I look at my red and I say, which way am I going to go? I know it has to be a 3 or 4. This is y is less than also. So as I look at this red line, below the red line would be everything over here. So of course it has to be 3 or 4. Since it's below, it's going to be 3. So I am going to shade in everything in between here. So that's going to represent my solution to that linear system, linear inequality system, I guess I should say. All right, let's look at this next one. Again, I'm going to make this one blue, this one red, so I can see the differences of the two lines. I'm still in red, so I'm going to start with red. This is y is greater than 5. So we go to 5 on our y-axis. 1, 2, 3, 4, 5. And because it's consistently y, this is going to be one of those horizontal lines. And there's no line underneath. So what does that mean? Yes, you're right. Dotted line. Put that dotted line in. All right, now I'm going to switch to my blue. You're my boy, blue. All right, start at -3. 1, 2, 3. And I go up 2 to the right 1, up 2 to the right 1. This is also a dotted line. So I'm going to draw a dotted line going through those 2 points. And I'm going to extend up because I know I have to get to the point where they intersect. All right, let's look at our quadrants. Here we go. Let's in no particular order. 1, 2, 3, 4. I got to figure out where they share. So if I look at the blue, this is y is less than. So blue is below the blue line. So it's going to be 3 or 4, not 1 or 2. So I'm just going to ignore those for right now because I know it's one of those two. And then I look at my 5. This says y is greater than 5. So my red has to be above, listed as above this red line. I know it's not in this section. It has to be this quadrant 4. So I'm going to be shading all of that line, and that is my solution. All right. One last one. We can go ahead and shade these, or pause this here and try this. So here we go. What do we notice about this? Same slope. What? Parallel? No way. That's crazy talk. Okay, let's go ahead. I'm going to do this one in blue, this one in red. So we got blue here. We go up to 4. 1, 2, 3, 4. That's my starting point. My slope is 2, so I can go up 2 over 1. It is a dotted line because no line underneath. So I'm putting my dotted line. All right, let's go ahead and do the red one. The red one, we start at -4. 1, 2, 3, 4. All right, and now I have my slope, which is 2. So again, up 2 to the right 1. Again, we know these are parallel, same slope. This is a solid line because it has a line underneath. So I'm going to draw this line through it. Mr. Drapel, you just said there was 4 quadrants. Well, not in this line because they're parallel. They don't intersect. But we can still shade where they share in common. So if I look at this blue one, y is less than means below. And this red one is y is greater than means above. Well, yep, you guessed it. We're talking about this part in the middle that they share. All right, so that is how you would solve for linear systems. writing a linear system, if I gave you a graph and asked you to do that, it would just be backing it out the opposite like the previous section. One other thing I can bring up is you can also use Desmos to check your answers. All right, so I brought up the Desmos graphing calculator. Let's go ahead and just type these in as we see them. So I'm going to type in my y and find that less than symbol, 2x, and then plus 4. Look at see, you can already see it's shading the parts that are below. So when I do this one, I have y. Oops, I can use lowercase, it probably doesn't matter. So I can use less than or equal to. So now instead of using the keypad, I can use this as well. So I can use less than or equal to, and then I have my -3 over 2. I'll use that arrow and put an x. All right, and then -2. And if I bring this up so we can see how it's this section right here, this is kind of very cool too. You can see how it's a little bit darker where they intersect. So you can still use Desmos to check your answers for all of these problems, just like we've been doing with any type of linear system, looking where they intersect. But it's a shaded region, not particular points on the graph. So have some fun with this. This is it's kind of a fun lesson once you get the hold of it and you can kind of really figure it out.